In our last lesson, we took a look at what vaccines are. So we're just going to do a little review of that, and then we'll get into different types of vaccines and the diseases that can be prevented by getting vaccinated. So what is a vaccine? Again, normally the typical form is an injection where you would get a shot. And no matter if it's that kind or an inhaled vaccine similar to a nasal spray, that is going to be made from very small amounts of either weakened or dead germs that are able to cause diseases. So that could be for viruses, bacteria, or toxins. And they're going to prepare your body to fight the disease both more quickly and more efficiently if you're exposed to it again in the future, to keep you from getting sick from that pathogen. How do they work? Again, still a review from last lesson. Depending on what type of vaccine, it's going to be part of the pathogen or possibly the entire thing injected into a patient. And included in the vaccine are going to be components that will trigger the person's immune system to create memory cells, but not enough to kind of have their immune system react so much that the person actually gets sick. If the person happens to be exposed to that particular pathogen in the future, then their immune system can respond more quickly to keep them from getting sick because they've already gone through the process of making memory cells. So here we have the diagram we went over again in our last lesson, and this initial part after you've been vaccinated is very similar to when you would actually be exposed to the pathogen naturally, except the dose of the vaccine is just enough to kind of expose your immune system to part of the pathogen or all of the pathogen. It's either going to be weakened or inactivated, so that either way it's unable to actually give you the disease and make you sick. But your immune system goes through the process of creating memory cells so that you have them to fight off the infection more quickly if you're exposed to the pathogen again. So after exposure, after your time of getting the vaccine, and it does, if I go back here real quick, this whole process takes about 2 weeks to happen because it's a lower dosage than you being exposed to the pathogen naturally. So you're going to need time, so you can, if you are exposed within that time frame of when you got vaccinated until you have full immunity, you can still get sick from that pathogen. But assuming that we're past that kind of usual typical 14-day period, if you're exposed to that same pathogen again, your memory cells are already made in your body to start cloning your B cells to make plasma cells to make antibodies, your killer T cells to destroy infected cells. So this process is drastically sped up from if you were exposed to it the first time, and that's how they're able to keep you from getting sick. So now that we've gone through that review, we're going to look at these different types of vaccines. We'll go through each one, and then we'll go through diseases that can be prevented by getting a vaccine. So first we would have live attenuated vaccines, inactivated vaccines, subunit recombinant polysaccharide and conjugate vaccines, toxoid vaccines, viral vector vaccines, and the newest vaccine technology, mRNA vaccines. So we'll start with the live attenuated vaccines. What is going to happen, or when we use these type of vaccines, it's going to use a weakened form of the pathogen, which is what attenuated means, that causes the disease. So it's very, very similar to the natural infection. So this type of vaccine creates a very strong and long-lasting immune response because it's using a weakened form of that pathogen. So the fact that it's so close to you being exposed to the actual pathogen itself, virus, whatever it might be, it's going to be usually lifelong lasting. Usually it only takes 1 or 2 doses. If you get a second dose of a vaccine, that's usually termed a booster. The vaccines that are live attenuated vaccines are the MMR vaccine, or measles, mumps, and rubella, rotavirus, smallpox, chickenpox, and yellow fever. Now, these vaccines do have a limitation to them because they cannot be received by people with weakened immune systems. So the reason for that is because it's such a strong immune response to this kind of vaccine. And it also has to be kept refrigerated. So if doctors are vaccinating in like a remote part of the world, these vaccines aren't able to really be given because there's no refrigeration in those areas. So that is a drawback to this type of vaccine. Next, we have inactivated vaccines, and this uses where live attenuated vaccines use the live virus, we'll say, for an example, just a weakened form of it, so that they weaken it so it can't make you sick. An inactivated vaccine is going to use a killed form of the pathogen, or a no longer active, we'll say, because viruses aren't living things. These vaccines don't provide immunity that's as strong as live vaccines do, and these might require several doses or boosters in order to get ongoing immunity. The vaccines that are inactivated vaccines are the Hep A vaccine, flu vaccine, which is for influenza, polio, and rabies. Next, we have subunit recombinant polysaccharide and conjugate vaccines. Any of these are going to use specific parts of the pathogen, or kind of pieces of the pathogen. So it could be a protein, a sugar, or the capsule that surrounds a pathogen. So it is exposing you to a specific piece of the pathogen, so it does give a strong immune response. These can be used or given to almost everyone, but they do require boosters. So you would need additional shots after your initial shot. This type of vaccine would include Hib, or Haemophilus influenza type B disease, hepatitis B, HPV, which is human papillomavirus, whooping cough, which is part of the DTaP vaccine, pneumococcal disease, meningococcal disease, and shingles. Next, we have toxoid vaccines, and this would use a toxin that the pathogen produces in the vaccine, and it can create immunity to the parts of the pathogen that cause disease instead of to the whole pathogen. So when you have an immune response after this kind of vaccine, it's targeted to the specific toxin instead of the whole pathogen itself. And it may require boosters. It depends on what it is. Like a tetanus shot, you would need a booster for. So it does protect against tetanus, and it also covers diphtheria. Would fall into this category of vaccine. Next are viral vector vaccines, and this uses a modified version of a different virus as a vector to deliver protection. So these are going to, the viruses we would use as the vector are going to include weakened or inactivated forms of the flu virus, measles, and adenovirus. Adenovirus is a type of virus that can cause the common cold. And what they do is they take a gene unique to the virus that they want to protect against, and they insert that into the viral vector, which then is able to infect a human cell, because that's what viruses do, and then it causes an immune response that way. So often viruses are used that can't infect humans, so it's not like they would use viruses from different species sometimes, because if somebody was already exposed to the virus and had immunity against the virus they were using in this vaccine, then they would already have immunity, and it wouldn't be able to infect their cells at all. These vaccines include the J&J or Johnson & Johnson COVID-19 vaccine. There's vaccines for Ebola, and studies are being done on vaccines to protect against Zika, influenza, and HIV. And then finally we have mRNA vaccines. These are new as far as being given to people on a mass scale. But mRNA is a nucleic acid, so it is able to, or it's made from like a gene's worth of DNA gets copied into mRNA. So what happens with this vaccine is they take mRNA for a specific gene, and they wrap it in a coating that lets it be delivered into the body, so it can be easy and able to keep the mRNA from being damaged by your body. So it allows it to enter your body easily again, but not cause any harm. And these vaccines actually teach your cells how to make copies of the protein that the mRNA would code for. For the example with the COVID-19 Moderna and Pfizer vaccines, they use mRNA that would code for the gene that codes for the spike proteins on the surface of the COVID-19 virus, or the SARS-CoV-2 virus. And then your cells make that mRNA, but it is seen as foreign, so you have an immune response to it once you make that protein. And then the mRNA is actually broken down by your cells, so that doesn't stay in your body at all. This type of vaccine has been studied in other diseases, such as flu, Zika, and rabies. So if you look here at different vaccine preventable diseases, you're going to be filling in the disease names on your notes. Okay, so first we have hepatitis B, or Hep B. It is typically spread by contact with blood or body fluids. The symptoms of Hep B, you could be potentially asymptomatic, meaning you have it but you don't show symptoms. You have fever, headache, weakness, vomiting, jaundice, which is yellowing of the skin and the whites of your eyes because it affects your liver, and joint pain as well. Complications of the disease include chronic liver infection, liver failure, and liver cancer. You would receive the Hep B vaccine to protect you against hepatitis B. And now the ages to receive this vaccine are 1 at birth. The second, and this has boosters to it. The second booster, or the second shot, which would be the first booster, would be around 1 to 2 months of age, and then the third shot, or the second booster, would be between 6 and 18 months of age. Next is rotavirus, and that is spread through the mouth. It can cause diarrhea, fever, and vomiting. Disease complications would be severe diarrhea, which would lead to dehydration. It's the RV vaccine that protects you against that. You would have 3 shots for this as well at 2, 4, and 6 months of age. Next we have diphtheria, tetanus, and pertussis. These are all covered by the DTaP vaccine. Diphtheria is spread by air or direct contact. You might have a sore throat, low fever, weakness, swollen glands in your neck, but complications include swelling of the heart muscle, heart failure, coma, paralysis, and death. Again, it's part of the DTaP vaccine that you would get when you are 2, 4, and 6 months of age, between 15 and 18 months, and then again at 4 to 6 years. Next we have tetanus, and this is exposure through cuts in the skin. So if you get a cut, for example, that maybe is, like if you got, we'll say like something rusty, like metal that has rust on it, you would definitely want to get a tetanus shot. So you do get boosters, and you can get boosters of the DTaP vaccine. But when you're older, it's a little bit different. It's called Tdap instead, where tetanus is the primary protection against offered in that vaccine. Tetanus can cause stiffness in the neck, abdominal muscles, difficulty swallowing, muscle spasms, and fever. Complications could include broken bones, breathing difficulty, and death, which is kind of, I guess, the ultimate complication. Again, it's covered by it would be the T in the DTaP vaccine. We already went through the ages. And pertussis is also called whooping cough. It can be spread through the air or by direct contact. You'd have severe cough, runny nose, apnea, which is like a pausing of breathing, and that can cause pneumonia or death. Next we have HIV, or Haemophilus influenza type B, which is spread through the air or direct contact. And this is caused by bacteria. There would be no symptoms unless the bacteria actually enter your bloodstream. But if that happens, it can cause meningitis, intellectual disability, epiglottitis, pneumonia, and death. It's the Hib vaccine. You would get that at 2, 4, and 6 months, and then between 12 and 15 months would be your 4th shot for that. Next would be pneumococcus. That is also spread through the air or direct contact. You could possibly have no symptoms, but it is pneumonia. You can have a blood infection, meningitis, or death from that. And it's the PCV13 or a pneumococcal conjugate vaccine. You get that at 2, 4, 6 months, and then 12 to 15 months again. Polio is spread through the air, direct contact, or through the mouth. Possible to have no symptoms there. You could have a sore throat, fever, a nausea, or headache, and it can progress to paralysis and even death. It is going to be the IPV vaccine, which is the inactivated poliovirus vaccine, and you get that at 2, 4, and 4 months, between 6 and 18 months, and then your 4th shot would be between 4 and 6 years of age. Next, we have influenza, which is the flu, and that's spread through the air or direct contact. You can have fever, muscle pain, sore throat, cough, and extreme fatigue. It can progress to pneumonia. It is the flu vaccine, and that should be received annually after 6 months of age. Next, we have measles, mumps, and rubella. Those are all covered by the MMR vaccine. Measles is spread through air or direct contact, as all mumps and rubella are as well. With measles, you get a rash, you have a fever, runny nose, and you can have pink eye. That can progress to encephalitis, pneumonia, or death. For mumps, you would have swollen salivary glands, fever, headache, tiredness, and muscle pain. That can progress to meningitis, encephalitis, inflammation of the testicles or ovaries, and deafness. And then rubella, you could have a rash, fever, and swollen lymph nodes. It can lead to miscarriage, stillbirth, premature delivery, and birth defects. And that would be at a later time if you were in older age, if you were exposed to rubella. So all measles, mumps, and rubella are all covered by the MMR vaccine. And this is the vaccine that had so much controversy around it because of a doctor who falsely claimed that the MMR vaccine was causing autism. And we'll talk about that at the end of this lesson. So you would get the MMR shot first around a year to 15 months, and then you would get a booster around 4 to 6 years of age. Next we have chickenpox. That is spread through the air or direct contact. You would have a rash, tiredness, headache, and fever, but it can progress to the blisters becoming infected and bleeding disorders, encephalitis, and pneumonia. That is covered by the varicella vaccine. You would get your first dose around a year to 15 months and your second dose at 4 to 6 years of age. And then finally we have Hep A or hepatitis A. That is spread through direct contact or contaminated food or water. You could be possibly asymptomatic, or you could have a fever, stomach pain, loss of appetite, fatigue, vomiting, jaundice, and dark urine. And complications include liver failure, joint pain, kidney, pancreatic, or blood disorders. Again, it's the Hep A vaccine that covers hepatitis A, and you would get that around a year to 2 years of age. So with part of that, before we go through this slide, I'm just going to go over kind of what we have here. And it says, I know you can read for yourself, but we're going to go through it anyway. It says, not vaccinating your kids leaves them vulnerable to disease their whole lives. When your daughter gets rubella when pregnant, how are you going to explain that you chose to leave her at risk? Because remember, rubella can cause miscarriages or birth defects in an unborn child. What will you say when she calls and tells you she has cervical cancer because you decided that she wouldn't need the HPV vaccine? What do you tell your son when he breaks the news to you that he cannot have kids thanks to mumps that he got as a teenager? And what do you say when he gives influenza to his grandma? How do you explain that she won't be coming home from the hospital? Not ever. Do you tell them that you didn't think these diseases were that serious? That you thought that your organic home-cooked food was enough to protect them? Do you say sorry? Okay, so while those seem like harsh and kind of extreme cases, it is possible for all of that to happen if we leave people unvaccinated. The goal of vaccination not only is to protect the person receiving the vaccine, is also to protect other people. So in doing so, that we can reach what we call herd immunity. And this is a term we use to describe how a population is protected from a disease after vaccination by stopping the pathogen that's responsible for causing that particular infection from being transmitted from person to person. It only works if the disease can actually spread person to person. It's not just like an individual thing that you would have to get, like tetanus, for example. You pick that up on your own. That's not spread from person to person. It depends on the pathogen, but about 90 to 95% of the population typically has to be vaccinated for this to work. By being vaccinated, it protects you from getting the disease, but again, it also prevents you from spreading it to people who are not able to be vaccinated. As we discussed last class, there are people who, for example, like are undergoing cancer treatments and can't receive vaccines. So it's kind of, I feel like it's our responsibility to get a vaccine to, again, not only protect us, but to also think about other people besides ourselves and help protect them as well if they are in that vulnerable population that can't get a vaccine. A point what we'll look at is smallpox. Smallpox is a virus, and you can see this poor child here that has smallpox. It causes painful fluid-filled blisters that all cover the body. About a third of the population of people that are infected by or were infected by smallpox died from it. So that's a pretty big percentage, 33%, roughly. So that's a lot of people if you think about it. Survivors were left with horrible scars. Some of them were left blind. So it's not just, okay, like scars all over your body, that would stink, but like you could live with that. But if you lose your sight, that's a much bigger deal. But through herd immunity, smallpox has been eradicated from our planet. People who, like my parents' age and slightly younger, I believe, have this scar on their arm, and that's from the smallpox vaccine. So here, this little cartoon says, this little girl saying, "What's that mark on your arm, Mama?" And she says, "It's my smallpox vaccine scar." Then the little girl's asking why she doesn't have one, and the mom says, "Because it worked." So because other people older than us got vaccinated for smallpox, that was enough to keep us from even needing the vaccine for smallpox because it got rid of that virus. And then lastly, we'll just touch on vaccines and autism. That absolutely is not a thing. There was I don't even want to say Dr. Andrew Wakefield because his medical license was revoked, but we'll say Andrew Wakefield. He was a doctor in the United Kingdom, and his medical license was stripped because he falsely published a paper that claimed a link between the MMR vaccine and autism. The measles, mumps, and rubella vaccine. And he stated that the virus received from the vaccine was causing inflammation in the gut or the intestines of children that impeded normal brain development. With his study, it included 12 children. Only 8 of those children were diagnosed with autism. Other doctors, other researchers tried to repeat his study to kind of verify his findings because he also had such a crazy small sample size of people that it was never. First of all, it's not a good study anyway when your sample size is that low, that small. But nobody, no matter what they did, could repeat his studies. And he also never compared the rates of autism in vaccinated versus unvaccinated children to see if the rate was higher in children that received the vaccine than children who didn't receive the vaccine. So we will say that, like mercury in vaccines, is, what causes autism, but, the MMR vaccine never had mercury in it at all in any form. So, there's really no claim for him there. And in the vaccines that had a form of mercury, that form of mercury our body is able to actually break down, whereas the mercury that is even in like the salmon, the food that we eat, is a different form that our body is not able to break down. So even looking at it that way, there's still no like correlation or causation where you could say that vaccines cause autism. Right. When you are finished your notes, please make sure you submit them.